Now, so I've got two identical networks. I created this first one, configured it all as much as it needed. I selected it all, copy, paste, and that's why there's a 1 in the brackets behind it, the ones on the bottom. So basically I've set up a network here now there's R1, there's ISP, there's R2. On R1, if we look at it, in show run. So I've set IP addressing on the Ethernet interface and serial interface. I've done a static route just so that this router knows how to talk to that router, but only the serial links are actually known. And that's pretty much all I've done. And so if I do show IP route, there is the directly connected network of 10.1.0, that's the WAN link, and then there's 172.16, which is the Ethernet link. And there's also the static link to the other WAN link. So that's all I've done there. On the other switch, on the other router here, I've just done something very similar, show IP route. And so again, remote WAN link, local WAN link, and then there's the LAN. Now, the other router didn't know about 17. This one doesn't know about 16. So the two hosts can't actually ping one another at the moment. They don't have, the routers don't have enough information. So ping 172.17.0.10 is the host number, and the router's saying don't know how to find that. Wrong text file. Now, so here are the configurations for GRE. So as the slide said, you do interface tunnel, and I've done 0. Tunnel mode GRE IP, and then you give it an IP address. Now, if you remember, the slide said you'd supply a tunnel source of IP address. That doesn't work on Packet Tracer, at least. It might depend on what model of router you're using. But tunnel source for the physical interface does work. Tunnel destination is the other end of the WAN link. So if you look down here, it's 10.0.2. And so that's the tunnel destination. And then again, I've done router OSPF1. But in the slides, it just had the one network. I've actually thrown in 2. So, of course, this here is the tunnel interface. And so I want OSPF to go over that tunnel link. I also want it to advertise the Ethernet from this end, and I'll hopefully learn the Ethernet from the other end, and all will be happy. And so then the host should be able to talk to one another after I've done this. So I'll do a copy, paste. No errors, I hope. Doesn't look like it. So again, if we do a show run, we've got this tunnel 0. We've got that IP address there. I didn't do an MTU command, did I? So it's obviously figured it out for itself. And then tunnel source of that physical interface, tunnel destination, the serial interface on R2 basically. Now that's one end of it done. I don't think I've done much else except for, no, I didn't actually show you this. This is the router OSPF, the 2 commands, and that is the static route just to the other end. Now, of course, I need to do the other router, R2, paste it in. Can't see any errors. tunnel interfaces come up, and OSPF has got full adjacency with a neighbour. And so the neighbour, of course, is that IP address. Now, OSPF was pretty cheap and dirty. I haven't done a router ID or anything like that. So it's not what you call a reliable setup. So let's do show IP route again, if I don't make typos. And so the routing table has actually learnt that network. So on router 2, it now knows about network 16. And router 1, hopefully it knows about network 17. So show IP route. And OSPF does seem to know. And so we've also got the extra routes for 192.168.2.0. And of course, so that's another directly connected network, which of course is on tunnel 0. So the next test is, can I now ping that host? Up arrow. It's not happening quickly, but anyway, probably an ARP request or two in there. Hey presto, look at that. So I've got a routing protocol running over an ISP link, basically. So that certainly would be a half-decent solution for joining sites together. Would be to run the GRE tunnel and have an ISP going over. Might want to encrypt it as well, but anyway. So that's a GRE tunnel. So let's do. We've got these extra interfaces. Show IP interface brief. Not wide enough, apparently. And so we've got this extra interface here. Tunnel 0, that's its IP addressing. Up and up are the status. So physical layer, data link layer. So it's all very happy. Okay, so that's a GRE tunnel. Now BGP. Again, so these two networks are identical, other than, one's just a copy of the other, and so there's a one in brackets behind everything. And so again, this host can't ping the other end. Ping 172.17.0.10. And so the router says no can do. So let's hopefully make it do. And so again, one router's BGP 65,000, the other one's 65,001. The neighbour, of course, is the other end of a network here. It doesn't have to be a directly connected neighbour, but of course your router does need to be able to find that address. So that's again why I've got that static route in there, so it can find the other end of the serial link. And of course, this is the network I wish to advertise to the rest of the world in this instance. And so, of course, the neighbour is the other end of the link and the other AS number, which of course is reciprocated here. And of course, this one's advertising network 17 to the world. So again, we'll just paste it in, see how we go. Don't see any errors. And there was an adjacency change for BGP. We have an up connection with that router. So if we do show IP route now, we have this source for B. And so again, we've got this working over the link. Again, must be an ART request at the other end. And we have success. So BGP is not hugely different. You just need to specify your neighbours. Because you're connected over the internet, you can't just sort of promiscuously connect to any old neighbours. You need to sort of be very careful about that. Let's say this is a different name, just so I don't blow away my original. So that's it for that. Now, what